Okay, so what I have here is I have IntelliJ running and at the point where I'm ready to create a new project. So I'm going to go ahead and do that here. Click Create New Project. And what you'll want to do is make sure that your Java version is the latest. And in my case, I've got 1.8. In our course, it's not going to be super critical which version you have, but I usually always check to make sure I've got the latest one, just to play it safe. And all this other stuff that you see, you can just blow past it and click Next. Here, again, you click Next. And at this point here, you give your project a name. Now, the project is not the file that you write your code in. The project is bigger than that. It contains a folder, and in that folder is your file. So what you're doing right here is you're naming the project or the container for your code. So this is usually the place where I will tell you to name it something like ch3asg or something like that. In our case here, I'm going to call this object example A, let's say, because let's say I do several examples. This would be A, and then I'd have B and C and so forth. It really doesn't matter what you call it, as long as you can remember where you put it and what you called it when you need to get back to it. But the other thing you'll notice is my project location. Now I'm running on a Mac, so this tilde here is my home folder, which in Windows it would be the Documents folder. And then underneath that I have an Idea Projects folder, and then inside of that I put all of my projects. So one of the things you might want to do at the outset is structure your system so that all of your Java programs go in the same place. Or another way of saying it is all of your projects are stored in the same place. This would also be true if you were running Eclipse or NetBeans. They all work the same way. They have projects that you build, and those projects are located in folders or directories. And all those directories, although they can be placed anywhere, it's better to put them all in the same spot. So everything I'm putting on this machine is going into Idea Projects. And then inside of that, I have my various project folders. Now, if I hit Finish at this point, my project is built, and here's my desktop. And if you're in IntelliJ, what you'll do next is you'll drop the little diamond here for your project folder, and then you'll notice it expands a bunch of subfolders, and there's one here named SRC. So what I'll do next is I'm going to right-click on the SRC folder and choose New, and then I'll choose Java Class. Now, I want to create an account class, but that's not the thing I'm going to be running when I hit the Run button. What I'm going to be running is the Account Manager class. So what I'm going to build right here is a class called Account Manager. Now you'll notice that this particular class is public, which it should be. The other thing I'm going to do is I'm going to create a main method in this class, because I want this to be the point where it goes to run my program. The other thing I'm going to do, as long as I'm thinking about it here, is put the comment header block at the top. So that would include the title of the program, the name of the author, the date, and the course, which in our case CIS 117, summer 2016, and then a brief description of the program after that. And again, it doesn't have to be a super detailed explanation. Just some sort of a purpose, overall purpose of the program is all I'm looking for there. Okay, so then the next step is going to be to go below that account manager class. So we're going to take and set him aside for the time being. We'll come back to him later. I'm going to bring the cursor down below that class. Notice line 16 is the closing cursor, the closing curly brace of the account manager class. It's right here on line 16. So on line 18, I'm going to make another class, and I'm not going to make it public. In fact, I can't make it public, because the way Java works is it only allows you to create one public class in a file. And that public class must match the name of the file. So if my class is called Account Manager, my file must be called Account Manager. They must be the same. Now, I can create as many other classes as I want to in this file, as long as only one of them is public, and that one must match the name of the file. Now, I could put this account class in a different file. In other words, I could go up to src and I could say new Java class, and I could name it account, and it would put two files in my project. And that actually is more typically how it's done, but for the purpose of this course, it's easier for me if you give me one file with everything in it than if you pass in 2 or 3 files, because then I have to open them all up, combine them together, and run the program. So this thing of having me have you put everything in one file is not very typical, but I'm doing it really to make my life easier in grading your work. Now, it's not the end of the world that we're doing this. It's just usually we like to separate every class into its own file. Okay, now this is the structure that you'll use for most all of your programs. You'll have one file with one public class in it, and then additional classes below that as needed. So our account class, we already mentioned that we're going to have some fields in it. We're going to put in some constructors. We have getters and setters, and then we have additional methods. So what I typically do is I put those comments in so that I have 4 sections in my class to put stuff, and I know exactly what goes in each section. So first of all, the fields. Fields are always private, and I have a balance, which is a double, and then I have a customer name, which is a string. That's it for my fields. Let's come back to constructors in a minute here. What we're going to do next is create the getters and setters. So first of all, let's take care of the balance. Let's do the getter first. The way a getter or an accessor works is you type in public and then the data type of the variable that you're giving the caller, and then the word get, and then the capitalized form of the variable name. So if it's lowercase b balance here, it's going to be uppercase balance here. And then in the body of the method, we simply return the variable, which returns the value inside of it. I also need to do the same thing for the customer name. So I'll say public string get customer name. Notice it takes no arguments going into the function. Nothing goes in, so these parentheses are just there, but nothing is placed within them. Now for the setters, the way those work is you type out public void, and then instead of saying get balance, we say set balance. And then in parentheses, you put in the data type of the field, which is a double, and then a variable name. And this variable can be called anything you want to be called. I'm going to put here the desired balance. This is what they want the balance to be. Well, this is a setter. Okay, they're going to be passing to me this desired balance. Now, if the desired balance is greater than or equal to 0, then I'm going to accept it. And I'm going to say that the desired balance, which was passed into the function, will be assigned to balance. Notice balance is in blue, and you notice when I click it, it highlights every instance of it. And in our case, there are 3. Notice one of the ones that gets highlighted is this one right here on line 21, telling you that it's a field, that I'm actually going to set balance equal to what was passed into this method. So it takes what they've given us and sets it. Now, if that desired balance had been negative something, it would have skipped this completely and not done anything. Now let's do our set customer name. Now because customer name is a string, typically we really can't do much validation with strings. There really isn't much we can do. I mean, we can do certain checks, but in our case right now, we're not going to bother with that. We're just going to take whatever they want the name to be and let it go through. So customer name equals the desired customer name. Now that I've got my getters and setters built, notice there are 4 methods here. I'm going to do the constructors. So first of all, I want to do what we call the default constructor. When you do a constructor, you type in public and then the name of the class. If it's the default constructor, you leave your parentheses empty, and then inside of this block, you don't have to put anything at all if you don't want to. And we're not going to. So if they want to create an account and not initialize it in the constructor, then we're not going to do anything to it either. We're just going to say, okay, if you want to build it with no initial values, we're just going to create it for you. But they might say, look, we want to create an account, but we want to pass in the customer name and the balance. In this case, we do want to take those in and pass them into the fields. Now in this case, in the constructor, when they want to initialize the customer name, we're going to call our setter. And we'll do the same thing for the balance. All right? So we have our 2 constructors. The last thing we need to do is to make our methods, and we have 2 methods. One is deposit, where they pass in an amount. The other one is withdraw, where they pass in an amount. For the deposit, we look at the amount, and the amount must be greater than 0. If it's greater than 0, then we're going to take the balance and set it equal to itself plus the amount. So I'm going to put a little comment here, and I'm going to say only perform if the amount presented for deposit is positive. Now, this is a place where a comment would be valuable, because somebody may look at this someday and wonder, well, why are they checking if the amount's greater than 0? Well, okay, they may figure it out in this case, but it's still nice in cases like this to have a comment that just says, look, you have to have a valid number here to make this work. I could also put this comment in the set balance method. And I could say the bank does not allow overdrawn counts, i.e. counts with, well, let me just say this, i.e. negative balances. So that would be another meaningful type of a comment, because some banks may allow a negative balance, and they like to charge all those lovely fees when you do that, when you overdraw. Other banks may not, or the same bank may or may not, depending on the type of account that the customer has. And so you run into things like this, and that's why it's good to have the comments there to describe what you're doing. Now, in the withdrawal method, we only want to perform a withdrawal if the amount presented for withdrawal is positive, and the other thing we have to make sure of is that it does not exceed the current balance. The way that we do that in Java is we put an if statement here, and we say if the amount is greater than 0. Now those two little ampersands there, I'll explain those in a minute. The second test is that the amount must be less than or equal to the balance. So what this is saying is it's going to ask a question, and the question has two parts. This ampersand separates the two parts for you. This is the first part, and this is the second part. Because of the double ampersands here, this is called a logical AND, which means both tests have to be true for the entire expression to be true. So what this says is the amount must be greater than 0, and the amount must be less than or equal to the balance. If both of those conditions are true, then this expression will succeed, and the code within the curly braces will run. If either one or both of these are false, then the code between lines 75 and 77 will not run. So assuming the numbers are valid, we will say balance minus equals amount, because we're withdrawing. So that is our class. We've built our class. We're ready now to go up to the account manager class, which is a completely different class. In fact, I'm going to put a little separator here just so that you can see that they're different. So they're completely different, okay? What we want to do up here now is to test the class that we just built. So the first thing I want to do is I want to create an account object with an initial balance of, and we had said in our testing strategy document that we were going to open this thing up with a $200 balance. We were then going to try the following actions. Deposit 500, deposit, I'll just do this. Deposit 500, deposit negative 500, withdraw negative 300, withdraw 300, and then withdraw 400. So let's also put what we expect to see . We expect a balance of 200 after we initialize it with 200. Here we expect a balance of 700 because we add 500 to it. A deposit of negative 500 would be rejected, so the balance would not change. It would remain at 700. A withdrawal of negative 300 would fail. The balance stays 700. A withdrawal of positive 300 would work, bringing our balance down to 400. And why did I put this last one here? I guess I don't need that one. So we're creating it, and then we're testing deposit with a positive and a negative. A withdraw with a positive and a negative. Oh, I know what I wanted to do here. I wanted to withdraw something higher than our balance. So if it's 400, then if I try to withdraw 500, the balance shouldn't change. It'll stay at 400. So let's double check this here. Initial balance of 200. If I deposit 500, I get 700. This should fail. This should fail. Here, if I withdraw 300, I should go down to 400, because 700 minus 300 is 400. If I try to take out 500, I can't do that because I'm overdrawn by 100. So that would fail, and my balance would be 400. Let's throw one last command in. Let's withdraw 400. That would give us a balance of 0. Now, let's go ahead and write the code here to do all of this stuff. Okay, so first of all, I want to create an account object. So what you do is you create an account object by typing in the name of the class, and then we need to create some kind of a variable, so I'll call it A1 for account 1. Set it equal to new account, and the two parameters that it needs, customer name first, and then we're going to put an opening balance of 200 into it. Now it says expect balance of 200. Let's create in this class another function called display account information or info. And this function is going to accept an account object called A. So remember, A is just a variable name. It's a placeholder. It's a pointer. It just says, look, somebody's giving us an object, and it wants us to print out the information inside of it. So we're going to call this object they're handing us A. I could call it B, X, I call it anything, but I'll call it A. So what I want to do here is I want to print out, using printf, the account for %s, and we're going to substitute where the %s is, the name of the customer. Then we're going to say has a balance of $%.2f, which rounds the number to the hundredths place, and then a period, and then a \n, which is a carriage return, taking them down to the next line. Now we have two parameters in this string, a %s and a %.2f. The first one is the string, and that we'll just use a.get customer name. And the second parameter is going to be a.get balance. So when somebody calls display account info, they're going to pass an account to it, and it's going to print out the information about that account. So we can use that up here. Right at this point here, we can call display account info and pass A1 to it. And it should tell us that the balance is 200. In fact, I'm going to use that same function every one of these places here. So I'm going to put that code, that same code, in every one of these spots. Oops, that did not want that to happen. Okay. Then, where it says deposit 500, I'm going to put the code in for that. You can see here, I'm using the dot notation to call the methods that I want to call to do these operations. Oops. it's very nice to have a nice editor like this to help you with color coding and things like that, so that you can catch your mistakes, sooner rather than later. Okay. So there's all my code, and I'm going to just right click and compile it to see if it compiles, and it does. So I'm going to go ahead now and run it, and I'm going to take this and just compare it here to my comments. So expect balance of 200, and it shows 200. 700 shows up 3 times. Then I have a 400 and a 400 and then a 0. So all of the numbers line up with what I expect them to show. So that tells me that my class is working right. Now let's say that I had a bug in my class. Let's say that I accidentally, in my withdraw method here, instead of doing minus equals, that I had done a times equals, which multiplies instead of subtracts. Well, when I run the program, obviously the numbers do not line up. So, you would then have to go and fix the problem, figure out where it's at, and fix it. But that's the reason that we do this testing here with these use cases, because ultimately we are probably going to take this account and other programmers are going to use it in their programs, or we're going to use it in our programs, and we want to make sure that this class works and there's no problems with it before it gets disseminated all across the development team that we're on. So we want to make sure it works right before we give it to other people. That's why we test it like this and use all these use cases to make sure it's working right. Now, as one final thought here, I could make another account, call it A2, call it Sally Jones, with an initial balance of 0. Well, let's give her $10. It'll be nice. And I could say display account info A2. Now notice what's happening here, right? We already have an account called A1. Now we're making another one called A2. 2 different objects, both derived from the same class. So they both share the same characteristics, yet the data inside of each of them will be different. Joe's account has various numbers in it. Sally's has 10 in it. Notice we're calling display account info a lot of times. Most of the time we're calling it an A1 is being passed into it. Now I'm calling it here with an A2. All of these objects, when they get passed down into display account info, those objects are temporarily referred to using A, not A2 or A1. When you're in this method, whatever object you pass to it is called A. Now, it's sort of like mailboxes in front of a yard. You're not making another house. If you look at an object as if it were a house, it's not like you have a house A1 and a house A2, so 2 houses, right? And then when you call a display account info and you pass the house to this method here, it doesn't make a third house. It just says, oh, okay, A2, I'm going to call you A. So both A and A2 in that case would be pointing to the same object. And it would be like having 2 mailboxes in the front yard. One mailbox would be called A2, one mailbox would be called A. They would both point to the same house. So when you think about variable names for objects, they are placeholders or pointers references, or what the formal term is. It's a reference to the object in memory. Now, in your assignment, you're going to be building something very similar to this in terms of structure. You're going to be building, instead of an account class, you're going to be building a race car, and your race car will have certain properties, and it will have certain methods that you'll build, and then you're going to go to test your class in this similar type of a structure with a main method, and make sure that your class is functioning properly. So you can use this example here sort of as a guide or a template or a starting point for the assignment that you've got for this chapter 3. So I hope you find that this is helpful. Watch the other videos. A lot of the videos that I have out there will overlap with this one, but I figure the more information I can present to you, the better. So hope you find this helpful, and if you have any questions or comments, let me know. We'll talk to you soon. Thanks for watching.